So let's take an example here of an appliance. This is a 5 terabyte appliance based on, in this case, a HP Blade Center platform. So you can see 7 enclosures. In this case, there are 8 blades per enclosure. I was getting slightly confused there with the new HPC class, which allows 16. But this is the thing in the marketplace. These products are coming through. We can just exploit them. So there are 56 blades present, Optron processors, disk, memory, and what you end up with is an appliance with about 5.5 terabytes of disk, and that is user disk. That is capacity available for user data, with no other cost in terms of index overheads or spooling overheads that you might require to run queries. That is pure data capacity. And then just under 900 gigabytes of RAM, which with low overheads is a hell of a lot of data you can put into memory to get high performance. And then switching and management servers. So where do we get the performance from? Well, we use scanning technology. Why? Well, because in an analytical environment, most operations aren't doing single record. Classic databases like the Oracles, DB2, SQL servers of this world rely on single row operations. That's their whole architecture and infrastructure. We work on the basis that in an analytical environment, users are engaging with high percentages of the data. They're accessing a whole table. They are running a computation on multiple large tables joined together. So our primary mode of access is through scanning. We use MPP, which means all servers, all disks, all processors are participating in your query. So all users, each query is getting the full performance of all of the hardware present. So that means there is enormous brute force power. If you imagine the 5 terabyte system I showed you earlier with 56 servers, with 112 processors, 224 cores. That is a lot of compute power. So some people regard us as a database supercomputer. Well, that puts us in a very rarefied area. We don't want to be that. But potentially, we can be used in this way. Currently, WX2 on an Optron-based system will scan data at 190 million records per second per server or node. So if you have 10 servers, 10 times that number. 100 servers, 100 times that number. That number will continue to change. So as Intel and AMD bring out faster processors, as HP and IBM bring out more performance servers, that performance will continue to scale. And as I've already mentioned, bulk data loading. The figure there of 600 gigabytes an hour, that's merely an example. It's something that we have proven to clients without any due course to special techniques or methods. I would fully expect to be able to do a terabyte an hour without any real issues. Now, people will say, oh, well, it's all too easy to sort of say this in a slide deck. So what I want to do quickly is just give you a quick taste for the performance. I have a 5 terabyte appliance available here now. I'm just going to show quickly, based on EPOS, that's an electronic point of sale supermarket data set, to give you a feel for what can be achieved. I'm going to use SQL. The reason being is it's very transparent. I apologize to any business users here that are not SQL literate, but this is as raw as it gets in interacting with the database. I can't hide behind any application or what the application may be doing. So we will do a simple scan of a table. Instantly, we get a response. We get a number back. And towards the bottom of the screen, if you're able to see this, where it says query 13, 1 row retrieved, 0.2 of a second. So we have 0.2 of a second to retrieve that information. Less than a second, 0.8, to bring the data back to the screen, 1.4 to finish everything up. Now that's a large number there. Let's just try that again with a bit of formatting. So again, we're going to repeat the operation. And you can see that there's 4.2 billion records present in this table. That's a hell of a lot of data. I've just gone through that twice in less than 2 seconds. So this is showing you the raw scanning performance available from WX2. Okay, easy, people say. Well, let's up the complexity. Let's do an operation. Let's start to profile that data. So I've just triggered a count distinct. Most database people regard this as a complex operation. It's very intensive. It requires the 4.2 billion records to be accessed for a particular attribute to then be profiled and to return a result showing there are 12,100 unique products. We were able to do that in 5 seconds. You may now start to get the feeling that speed of thought is now manageable, because most people have a hard time just assessing these queries before we've even brought the results back. I've just triggered another query now. We're doing 3 count distincts. In a standard database, in terms of the Oracles, DB2, SQL servers, that kind of operation will be frowned upon. DBAs would complain if users started to run queries like that. We've seen a response time there in about 14, just under 15 seconds to generate 3 very unique values based on the data. If the data changes and I fire that query again, we'll get the new result as of the data refresh. We can profile data. We can see the SQL is getting more complex. This is a week-by-week profile. It shows for a given week what the total number of items sold and the total value of those items. We've also added in some analytical SQL to bring the cumulative values. So what I have just done is I have produced an aggregate table, a cube, some people would say, on a 4.2 billion row data set in 2.2 seconds. This is where we place the idea of analysis at the speed of thought. I haven't had to pre-prepare the data. I haven't had to produce any summaries to achieve this. I've dynamically computed this from the raw data present. Let's just do one more. This one is doing computation. This is a double layer aggregate. I work out, based on the number of items in baskets, for all of the shopping baskets, and then compute the average on a per store basis. And again, dynamically in around 14, 15 seconds, I have computed that for 4.2 billion rows worth of data. And keep in mind that I don't regard this system as being a particularly large system. This is 5 terabytes of raw data. Whether you want to scale it to 50 terabytes or take it down to, say, a terabyte, you can still achieve this level of performance.